So welcome in this lecture of hyperbola. This is one type of hyperbola. This is called rectangular hyperbola. Means at last I will explain that what is the utilization of this. Now see, this is a question given. The question given is two lines OA and OB. I already drawn these two lines. Two lines OA and OB are at 90 degree to each other or perpendicular to each other. And one point P is 20 mm suppose and 30 mm. 20 and 30 mm from these lines. Now you have to draw a hyperbola passing through P. Means we have only one point, that is P. And we have to draw the hyperbola passing through this point. Okay. So first of all, I draw this initial two lines OA and OB, which are at 90 degree to each other. Now I am going to take a point P, 20 mm from one line and 30 mm from another line. So you know how we take a point. Take here, suppose this is 20 and this is 30. This is 30. Now draw two parallel lines, one from this and another from this, parallel to OA and parallel to OB. So this is a line parallel to OB and this is a line parallel to OA. So in this way, this distance is 30 and this distance is 20. So this is our point P. This is our point P, which is 30 mm and 20 mm from two fixed lines OA and OB, which are at right angle to each other. Now we have to draw a hyperbola passing through P. Now I am going to start the method. Now see, take point number 1 here, anywhere. This point you can take anywhere. But why I am taking here, that you will already know about after completion of process. This is point suppose 2. Suppose this is point 3. This is point 4. This is point 5. And suppose 6. Now like this, you have to take some points. This is point 1. This is point 2. This is point 3. This is point 4. This is 5 and this is 6. Now you have to join these points to O. See here, for 1 and 2 we have to join to O and extend up to where? See here. Join 1 to 2 and extend till it intersects on this line passing through P. Okay. So this is our point 1 dash. So now you understand how we get point 1 dash. 1 is assumed, and if we join 1 to O and extend on this line, we get point 1 dash. Now like this, we get all points, that is 2 dash, 3 dash, etc. Same way, by same process, you join 2 to O and extend. Here you get point 2 dash. Now if we join O to 3, we already get intersection here. So this is our point 3 dash. If we join O to 3, we already get an intersection point on this vertical line. So this is our point 3 dash. Now if we join 4 to O, same way, you can get point 4 dash. You can get point 4 dash. This is your 4 dash. And same way, join O to 5. Join O to 6. You get point 5 dash and 6 dash. So we have points 1, 2, 3, 4, 5, 6 and 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash on horizontal and vertical line. Now we have to draw again parallel to OA and parallel to OB lines through these points. Now how? See, from point 1 we have to draw a line parallel to OB like this. And from point 1 dash we have to draw a line parallel to OA like this. So this is our point P1, means first point for hyperbola. Next, now we have to draw line parallel to OB, line parallel to OB through 2 and parallel to OA through 2 dash. From 2 dash we have to draw line parallel to OA and from 2 we have to draw line parallel to OB. The intersection of these 2 points gives us point P2 and P point already we have. Now we draw same thing, same construction repeat. From 3 dash draw parallel to OA, from 3 draw parallel to OB. So we get point P3. Next, from 4 dash we have to draw parallel to OA. From 4 we have to draw parallel to OB. So we get point P4. And same way from 5 dash and from 6 dash we draw lines parallel to OA and 5 from 5 parallel to OB, from 6 parallel to OB. If we want, we can draw these all similar lines at a time, such that through 1 dash, 2 dash, 3 dash, 4 dash horizontal lines, through 1, 2, 3, 4, 5 vertical lines. Okay, so this gives us point P5 and P6. So these are the our points which are required for completing our hyperbola. Now I am going to complete the hyperbola. See here, join these points with a free and smooth curve. See, through these points we have to draw a smooth curve. This is called rectangular hyperbola. Rectangular hyperbola. Now what is its application? Now see here, if you know Boyle's law, that is PV is equal to constant. Means if we mark pressure on this axis and volume on this axis, and we know only one point, one pressure and one volume, then we can draw this curve, and this curve represent Boyle's law. Means PV is equal to constant. Means any point you can find pressure and volume. At any point you can find pressure and volume. If you know only one point, means one pressure and one volume. So this is the practical application of rectangular hyperbola. Okay, so I stop here, and in next lecture we will take another curve. Okay, bye.